Believe it or not, a dinosaur is still living on Earth today. Not a creature that simply looks like one. Not a distant relative. Scientifically speaking, it is a dinosaur. For millions of years, enormous creatures ruled the planet. They were larger, stronger, and more terrifying than almost anything alive today. And then, they disappeared. But one branch of their story survived. Today, scientists can look at a few fossilized bones, buried beneath the earth for millions of years, and create an image of an animal that no human being has ever seen alive. They can estimate its size, its posture, the way it moved, sometimes even the texture of its skin. But how? How can a skeleton tell us what an entire animal looked like? How can scientists know whether a dinosaur had scales, feathers, or something else entirely, when all that remains may be nothing more than ancient bones? And what about its voice?
For years, scientists debated the sound of the T-Rex. Was it a roar, a rumble, or something far more subtle?
Did dinosaurs really sound like the monsters we hear in movies? Or have we been looking at an imagined version of these animals for generations?
Once depicted as a slow, tail-dragging behemoth, new evidence reveals a dynamic, powerful predator.
The answer begins with a discovery that shocked the scientific world. When paleontologist Mary Schweitzer examined a fossilized Tyrannosaurus rex bone and found something inside it that should not have been there. The answer begins with a discovery that shocked the scientific world. In the early 2000s, paleontologist Mary Schweitzer was studying a fossilized Tyrannosaurus rex bone. The fossil dates back millions of years. Under normal circumstances, scientists would expect the original biological material to have completely disappeared after such an enormous amount of time. But when Schweitzer and her team examined the fossil, they reported structures that appeared similar to blood vessels, along with other remnants of soft tissue. The discovery was extraordinary. If even traces of biological structures could survive inside a dinosaur fossil for millions of years, then fossils might contain far more information than scientists had once believed. But this discovery also raised an important question. How much can scientists really learn from the remains of an animal that disappeared millions of years ago? The answer begins with the skeleton. A skeleton is not simply a collection of bones. Every bone has a shape. Every joint has a function. And the way those bones fit together can reveal how an animal stood, moved, hunted, and lived. The bones can show where muscles were attached. The structure of the pelvis can reveal important information about the animal's body. And the shape of the limbs can help scientists understand how it moved. But bones alone cannot tell us everything. To understand the dinosaurs, scientists first had to understand what made an animal a dinosaur. But bones alone cannot tell us everything. A skeleton can reveal a lot about an animal, but it cannot tell us exactly what the animal looked like on the outside, cannot always reveal the texture of its skin, cannot tell us with certainty what color it was, and it cannot tell us exactly what it sounded like. This is where paleontology becomes more than simply studying bones. Scientists combine evidence from fossils, anatomy, biology, and comparisons with animals alive today. Sometimes, fossils preserve more than bones. In rare cases, an animal can leave behind an impression of its skin in soft sediment. The original tissue disappears over time, but the impression can remain. These rare fossils are known as skin impressions, and they can reveal important details about the outer surface of an extinct animal. But even then, there are limits. Scientists can discover evidence of scales. They can sometimes find evidence of feathers. And in rare cases, other soft tissue structures may be preserved. But a fossil is not a photograph. Every reconstruction is an interpretation based on evidence. Some details can be known with a high degree of confidence. Others remain uncertain. And this is why the dinosaurs we see in documentaries, museums, and films are not always identical. They are scientific reconstructions. The closer scientists look at the evidence, the more complicated the story becomes. Because dinosaurs were not all covered in the same type of skin. Some had scales, some had feathers, and some may have looked completely different from the image most people have in their minds. The question is, how much of their appearance can science truly recover? But before scientists could reconstruct what dinosaurs looked like, they had to answer a much more basic question. What actually makes an animal a dinosaur? It may sound simple, but scientifically, the answer is far more complicated than most people realize. Not every ancient reptile was a dinosaur. Some lived in the oceans, others ruled the skies, and many lived alongside dinosaurs without actually being dinosaurs themselves. So scientists needed something more reliable than appearance. They needed clues hidden inside the skeleton. One of the most important clues was the structure of the hips. The way the bones were arranged could reveal how an animal's legs connected to its body and how it moved across the ground. Scientists also examined the skull, the limbs, the vertebrae, and many other parts of the skeleton. Then they compared these features between different fossil animals. Little by little, patterns began to appear. Animals that shared certain anatomical characteristics could be grouped together. And these relationships helped scientists build the dinosaur family tree. But the story became even more surprising, because dinosaurs were not one single type of animal. They were an enormous group that changed dramatically over millions of years. Some were tiny, others were enormous. Some walked on 2 legs, others moved on 4. Some were fast predators, others were massive plant eaters. Yet beneath all these differences, there were anatomical clues connecting them. And this is where science begins to reveal something remarkable. The dinosaurs were not simply strange monsters from the distant past. They were part of a much larger evolutionary story. A story that did not completely end when most dinosaurs disappeared, because one branch of the dinosaur family tree survived. And today, that branch is still living among us. The evidence is not just in the fossils. It can be found in anatomy, evolution, and even in anima. The idea that dinosaurs might still be connected to animals alive today seems almost impossible. But scientists do not rely on appearance alone. They compare the evidence. And one of the most interesting comparisons comes from the skeleton. Modern birds share several features with certain theropod dinosaurs. Their bones show clear similarities. So do their hips, limbs, feet, and overall skeletal structure. But the similarities do not stop there. Scientists have also discovered fossils of dinosaurs with feathers. And this discovery changed the way researchers imagined these animals. For a long time, dinosaurs were often portrayed as creatures completely covered in scales. But some fossils tell a different story. They show feather-like structures in certain dinosaur species. This does not mean that all dinosaurs had feathers, just as not all dinosaurs had the same type of skin. Instead, it adds another piece to the puzzle. Scientists can compare these structures with those found in birds alive today. They can also compare bones, claws, feet, eggs, and evidence of nesting behavior. When several different features point in a similar direction, it becomes harder to ignore the similarities. But there is an important point. Similarity does not mean that every bird simply looks like a dinosaur. And it does not mean that every dinosaur looked like a bird. The evidence is much more specific than that. There are shared features. There are structures found in both groups. And some fossils preserve combinations of features that make the connection even more interesting. And this raises the real question: how deep could the similarities between birds and dinosaurs actually be? The question becomes even more interesting when scientists look beyond the obvious similarities, because some clues are hidden in details that are easy to overlook. Take the feet, for example. The arrangement of the bones and claws can reveal surprising similarities between certain dinosaurs and modern birds. Then there are the eggs. Fossilized dinosaur eggs and nesting sites can preserve clues about how these animals behaved. Some nests show that dinosaurs did not simply scatter their eggs and leave. The arrangement of the eggs can provide evidence of organized nesting behavior. And then there are the bones themselves. Some dinosaur fossils preserve structures that can be compared with those found in birds. The similarities are not always obvious at first glance. Scientists have to examine the details carefully. A single feature may mean very little, But when several independent features appear together, the evidence becomes much more interesting. And this is one of the most important ideas in paleontology. Scientists rarely depend on one clue. They build a picture by comparing many different pieces of evidence. Bones, feathers, claws, eggs, nests, and other preserved structures. Each piece tells only part of the story. But when those pieces begin to fit together, a much clearer picture starts to emerge. And yet, there is still something we cannot see. The fossils can preserve bones. They can preserve impressions. Sometimes they can even preserve remarkable details of the outer body. But they cannot show us everything. They cannot tell us exactly how a dinosaur moved through its environment. They cannot always reveal every detail of its appearance. And they cannot preserve every sound it ever made. So scientists have to work with what remains. And sometimes, what remains is enough to completely change the way we imagine the past. But if the physical evidence can reveal so much, what else could scientists discover by L? But perhaps the most interesting part of this story is not what scientists know. It is what they are still trying to discover. Every fossil gives us another clue. A bone, a footprint,
A fait d'heure impression.
a nest, sometimes even a tiny detail preserved in rock for millions of years. And with every new discovery, the picture becomes a little clearer. But it can also become more complicated, because the past does not come with a complete record. Scientists have to piece it together from fragments. They compare what was preserved. They question what is uncertain. And sometimes they even have to change ideas that once seemed obvious. That is what makes studying dinosaurs so fascinating. We are not simply looking at creatures that disappeared millions of years ago. We are trying to understand a world that left behind only pieces of itself. And perhaps the next important discovery is already hidden somewhere inside a rock, waiting for someone to notice it. So the next time you see a dinosaur in a museum or in a documentary, remember that what you are looking at is not simply an image of the past. It is a scientific reconstruction, built from clues that survived an unimaginably long journey through time. And the more closely we look, the more questions we find. What did these animals really look like? How did they behave? And how much more of their story is still waiting to be uncovered? Maybe that's the most fascinating thing about dinosaurs. We may never know everything, but there is always another clue to find. And if you enjoyed exploring these clues with us, subscribe to the channel, because there are still plenty of mysteries from the past waiting to be uncovered.